Hello guys, my name is Max. Welcome to this episode on the tutorial on how to create a classic Metroidvania game in Unity. Last episode we created a tile map. As you can see, I changed the tile map again. I created a new one because I was unsatisfied with the old one, and I think it turned out to be much better. It's not perfect yet, since I think the contrast between the floor and the background is not optimal, but for the start we can work with that. I will put the tile set and all assets I'm using, or not all assets, are assets I made for this game. I will put it on EEach.io so you can use this yourself. Link for that is in the video description. Today we want to change the player. We want to add animations for the player. I was looking on EEach.io for an animation, and I discovered this one. I think this is pretty good. You can check it out. I will put the link for this one also in the video description. I already downloaded it. Here you can see the folder. So we go to sprites. Here you can see the different animations. It's simple how to import this in Unity. We go into our assets folder and we created a sprites folder. If you don't have a sprite folder yet, I suggest you to create a sprites folder. We go into that sprites folder and create a new folder for the player. So, and now we go to the sprites folder and we drop all the animation sprites into this folder. Perfect. So the first animation we want to add is an idle animation. An idle animation is an animation that is played when the player is doing nothing, like only standing around. So he's just standing there and doing like something, body movement of breathing or something like this, so he doesn't look stiff. This is the idle animation. What we have to do now, since we are in a game where every tile is 16 pixels wide, we have to change pixels per unit to 16. We also have to change single to multiple, because in that sprites there are multiple pictures. Then we have to change to point no filter, because we are using pixel art, and now compression. I'm sorry guys. We do apply this. You can also select all sprites and already change this for all sprites at one time. You save a little bit time doing it this like so. Perfect. Apply. And now we go to on the idle animation. We go into the sprite editor and we see, okay, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pictures in this animation, and we want to divide each frame. So we go to slice and we slice by grid, by cell count, and we have 10 cells horizontally, so we change that here to 10, and you see automatically it does the slicing evenly, and we slice it, and then we can apply. We close the sprite editor and you can see in this picture now we have 10 frames. Now we create a folder for our animations. And now you select all 10 frames and drag it and drop it into our scene. Then this dialog will appear. You go into the sprite in the animations folder, and we call this animation player idle. We save this. And then we can make a test and click on play. And you see now the animation is in the game. And it looks very good. It does fit the scenery, I think. Perfect. But how we do change now the animation of our player? This is easy. We close the player. And now we go on to the play. We can delete this animation we dropped in the scene. We go to player and we have to add a new component, and this component will be an animator. This animator needs a controller, and when we created the last the idle animation, it automatically created an animation controller called idle 0. It's the name of the first frame. If you double click on this animation controller, it looks like this. First, we rename the the animation controller to player animations or something like this. Secondly, we go to player and we have the animator on the player, and we drop that controller here. And also the sprite renderer, we have a sprite renderer, it's still the white capsule. We want to change that. We go to sprites, to the player, and we look for the animation into the idle animation, and we choose the first frame from the idle animation and drop that into our sprite renderer. So now let's look us on the scene, and now the player changed. But you can see the green line here is the capsule collider, and our sprite is larger than the capsule. So we have to change the size of our capsule collider to something like this. And maybe a little bit wider. Yeah, okay. Okay, this should work. Maybe. Yeah, this is perfect. And now we started. So now our player is animated. But if we work, you see, at first he doesn't change the directions. This is something we have to add in the code. And if we walk, he doesn't change the animation. And you have to do this in code. Yes. So now comes the more difficult part of this episode. First, you should create the animations you need, like the run animation. So you repeat the process I have shown you with the idle animation. So we will kind of skip this. So now we created 3 another animations we will need today, and you have to drag them, drop them into the player controller. So we have player fall, player jump, and player run. So our default animation is a player idle. And when you start to run, you want to play the run animation. So we have to make a transition from the idle animation to the run animation. And we have also, we don't need this. you have also add parameters. So we switch from layers to parameters and create a new parameter, and one parameter could be bool for running. And you have here the inspector for the transition between the two animations. And first we say it has no exit time. We want to play the animation immediately, and we have one condition, because our condition is that running is true. When we stop the running, we want to say the player, okay, you stopped running, so you can change the animation back to idle. So we make another transition, and here we do the same, and but our condition is that running has to be false. Okay, this is the first one. The other ones we want to add later. So now we go into the script for the player. So now we are again in our player script, and the first thing we have to add, because we have a new component on our player we want to control, we have to add this component to our script and say our script where to find this component. The new component we want to use is the animator. So we want to add this directly behind our widget body, another component which is used in this script. So we add animator, and we call that animator player animator. Now when the script is starting, it has to look for that animator, and we adding this and start and say, okay, we adding this and start and say, hey, our player animator is the component, and we say get components, so it will look for the components that are attached to the game object. So we say get component, and now we want to say for which component it has to look, and this is the animator. Okay, and this is, and on that way it knows which component it has to use. Now we can use the player animator, and we will use the player animator on move, because if the movement input is higher than 0, then the animation should change to running. So we have to set the bool in running, the running bool, on true. And so we make the if question, if movement input point x is higher than, let's say, 0.01 f, then this should used. So, okay, if the player movement is higher than 0 and the movement input is higher than 0, you use the command setBool on the player animator. Player animator point setBool. Which bool? It's not warslide, it's, I think, running. Did we call it running? I will take a look. Yes, indeed, we named it running. So, and then running should be true. Else, so if if movement input is below that threshold, then the running bool on our player control animation controller should be false. We save that script, and now we go into the game. The script will be compiled. Okay. Okay. I know what I did wrong. So you see, guys, he only will run if we run in one direction. That's because our movement input point X can be higher than 0 and also can below 0. So we should use a math function for the absolute value. So here, you guys, in the Unity documentation, you see the math function for absolute value. It will make from every minus value a positive value, and that should solve our little bug we made, or I made, to be honest. So we use it on the movement input. And we make another test. Yes, so now it should work. Okay, I'm sorry, guys, for all the mistakes I do. And now it works, but our little sprite should change the direction in which he is looking, and for that we need to change the sprite renderer. You see the sprite renderer here, and we want to change it on the X value, and we don't want to do that manually, so we have to add this in the script. So again, we go into the script, and now we want to use another component on our game object, and this one is the sprite renderer. And for simple reasons, I call this SR for sprite renderer. You add the sprite renderer to the script. Don't forget to look for the right component with SR equals get component sprite renderer, and then we use the sprite renderer again in our move function. So if the move input gets higher than a positive threshold, we want to go in the false direction, and if the move input change into the negative threshold, then we want to change in the true direction, and this little code will do the trick, and we will test it. And now you see we change directions, but still his animation is a little bit fast and he isn't running that fast. We should change that. And we do change that, and we go into sprites, then again player, animations, and we go into the animation controller. And now you can change the speed of the animation here. We go on the animation we want run, on the run animation, and we change the speed to the half. And we will test it if it looks good. It looks still a little bit weird, but okay, I guess it's enough for our thing we doing here. So And we still have to add another animation. We want to add the jump animation, and the jump animation is a little bit more complicated since the jump animation consists of two animations. The first is the jump when we are jumping in the air. And the next animation is a fall animation when the velocity of the player change and we are falling down. Then should be played the fall animation, and the fall animation also should be played if we falling into a pit. So how we are doing that? At first, you have to add the transitions to the animations. So we put the run animation into here and the player fall animation here. The first thing is you have to consider from all animations you can fall. Like, no, that's not true. You can fall when you run into a pit, and you can fall if you are jumping high. So this two needs transitions. The next one is the fall animation. If you are landing on the floor, you make a transition into the idle animation. And if you landing on floor but you are still running, you make a transition to the run animation. And you have to consider you can jumping standing and you can jump on running, so those two also needs transitions. This should be all transitions. Firstly, here you can add, so for all transitions we want to change that, and this has the first condition that running have to be true, and we want to add another bool here, and we call that bool grounded. So when the player grounded, he is not longer falling, so we can change that that to grounded is true. On this side it's similar, but running have to be false and grounded have to be true. And we will add another parameter, but this will be float, and we will call it something like velocity or force or something like this. And I think this have to be negative. I'm not sure yet. Also here. And we can build a trigger for jumping. So okay, and now we go to the script again. Okay, as soon as we are pressing jumping and the player jumps, we can add that we are setting the trigger of the player animator, which was jumping, and we can do this in the fixed update function, that player animator set bool grounded is always the same as a grounded variable in the script. Was it the right name? Yes, it was correct. Okay. we will firstly, now we have to add the velocity. For the velocity, we have to use rigid body. And yes, we can also do this here in fixed update. We are setting the player animator, set bool, but this time we want to set a float, and we call this float in the animation controller velocity, and we want the velocity on the y-axis for that, and that should do the trick mostly, I think. So we have to test it. Okay, now compiling errors, this is cool. Oh yes, it works. Okay, perfectly. So, this was the episode for today on how to add animations of our player. I think it looks kinda cool. Huh. So also props to the guy who creates the animations. I think the falling animation with the floating coat of the knight, it looks very, very epic. Okay, very cool. So see you guys on the next episode. I want to introduce something like a map on the game. I think it's a very important key feature of every Metroidvania, so we will do this on the next episode. And after the map, we can do something like camera movement. And the camera movement will probably be a long episode. Maybe I will make like different episodes only on the camera movement, because I developed a script that is dealing with the classical Metroidvania camera movement, where the camera aligns to the different rooms. So keep that in mind. Probably I don't know yet when I will upload the different episodes. If I will start soon to upload the episode, it can be that there's a break because I'm moving to another city for a new job. Maybe I will wait for uploading it, and then there's no problem with the schedule on uploading the videos. Okay, but anyway, I hope I can see you soon again, and until that, have a nice day.